Thank you everyone for joining again for the lesson. And today we are going to discuss about the structure questions that you have done. Okay, please get ready with the structure question that we have done yesterday. Question number 1. Okay, now this is the question shown to given to you. Experiment is carried out to investigate the rate of reaction between the magnesium and the sulfuric acid. Now please get the keywords. The magnesium, and the sulfuric acid. Okay, we know that we are having a metal and a non-metal. Go on now. Okay, now we are going to continue. Now the keywords here given to us will be the magnesium reacting with the sulfuric acid. Now why is it important? Because from here we are going to get our chemical equation. And also, can you see excess magnesium powder, meaning this will be extra. This will be excess, and the sulfuric acid is the one which will determine whether the reaction will stop or to continue. This is the limiting reactant. Now, when this reaction occurs, the volume of gas collected is recorded at 30 seconds interval. Now, from here, did you see 30-second intervals? Now, did you see the volume of gas? 2 decimal places recorded. Now, predict what is the apparatus used to record the volume of gas released. Now, the answer here will be the burette. Okay, why? Because of the 2 decimal place. Now, from here, we are asked to get the gas which is released. Can you see the word name? Name means we have to spell out. Now, how do we know the gas which is released? We have magnesium, which react with this. We have magnesium, which react with the sulfuric acid, which is H2SO4. Now, when this reaction occurs, you are getting magnesium sulfate and the hydrogen gas. Okay. Now, balance up the equation. You are going to have the hydrogen gas being produced. Therefore, the name of the gas which is released will be hydrogen gas. Okay. Now, next part. Based on the table, can you see you plot a graph? Plot a graph means you have to have the graph paper. Each of the dot will be put into this the graph paper. Now we continue. Can you see the volume of gas comes first? So this is the y-axis and the time will be the x-axis. Okay, next part. Now continue. I'm going to show you the graph that you should have plotted. Okay, now we continue on. I'm going to show you the graph that you should have plotted. This should be your graph. Can you see this graph? Make sure you are putting this as the uniform scale. Uniform scale means if this from here to here is 10, so from 10 it will be 20. Okay, and this is the y-axis, uniform scale as well. Now, can you see the title? The title with the unit written. The title with the unit written. If you have no unit written, then you are going to lose your marks. Next part. Please put the pointer all correctly. And you are going to join all the dots using a smooth curve. Okay? Now, next part. We are now going to, I hope you are okay with that graph just now. Now we are going back to our question. Now, our question next will be asking us to calculate the rate of reaction. Can you see the word at? At, okay. When you get the word at, meaning you are actually calculating the instantaneous rate of reaction. Again, I am telling we are calculating the instantaneous rate of reaction. Okay. Now, instantaneous rate of reaction meaning you are going to get a tangent at the points identified. Okay. And for this part, I'm going to show you the answer later. Now, let's move on to the overall average rate of reaction. Now, when we are talking about the overall average rate of reaction, we are actually talking about the rate of reaction when we are talking about the change of volume divided with time, which is the average rate of reaction. Okay, now we continue. From the table here, from this table, okay, look at this. Now, at what time does the volume of gas start to remain constant? Okay, and I hope that you may identify this. See, 45 centimeter cube is the maximum volume. Okay, and the time reached the 45 is 210. Therefore, the overall rate of reaction will be the volume divided by time, which is this. I'm sorry, this should be minute, and you are actually you should change. Everyone, please change for me. This time here from the minute, this one, the minute change to second. Okay, unit is the second. So you are actually taking the 45 divided by 210. Okay, and you should be getting this as your answer. Okay, so yeah, you should be getting 0.214 centimeter cube per second. Now I go back to the part on the instantaneous rate of reaction. Okay, see ya. This is the 120 seconds. Just now they asked us to get the rate of reaction at 120 seconds. So we go up. Now this is the point. Therefore, you are going to get a tangent, the blue line, which touch this point only. Make a triangle, get the coordinate at this part, and you get the coordinate at this part. Okay. Now, from the coordinate, you are going to calculate the rate of reaction at 120 seconds. Let's say this is x1, y1, x2, y2. So you are actually getting the x1, the x2, the y2 minus y1 equals the y2 minus y1 over x2 minus x1, and you are going to get the gradient. The gradient is the rate of reaction. Now, if you are getting an accurate answer, your answer will be 0.183 centimeter cube plus minus 0.05. Now, what does it mean? Meaning, your answer can be 0.185 plus 0.05, which is 0. If you are adding in a 0.05, then you should be getting your answer. The highest will be 0.235. Okay. If you are you minus, meaning you are getting your lowest answer will be 0.135. Okay, I repeat now. The range of your answer here, what is the meaning by this? Meaning you take this 0.183 plus this value, or you take this minus this value. So your answer should lies between 0.135 to 0.235 in the unit of centimeter cube per second. Okay, that is the meaning of this part. Now we are going to move on. Look at our question. Look at our question. Now this part. Another experiment is carried out to investigate the factors affecting the rate of reaction. Curve L represents the result using excess magnesium powder 50 centimeter cube, 1 mole per decimeter cube of hydrochloric acid. Okay, the L is the initial one. Now, when you want to suggest the factor that influence the rate of reaction to obtain curve K. Curve K, look at curve K. Okay, see that? This curve K, did you find that the rate of reaction is higher than L? Why higher than L? Because the gradient is higher, steeper. Okay, but the time taken to complete the reaction is shorter. Okay, gradient steeper and the time taken to complete the reaction is shorter, meaning to say this K, the rate of reaction of K, rate of reaction of K is higher than L. Okay, but the total volume of gas collected is the same. Okay, so now what can you do to make the rate of reaction to be higher? Can I have answer from you? Should we hear from Jasminder? What is your answer?
Teacher, I put concentration of hydrochloric acid is the factor that influence the rate of reaction.
Okay, now if you are putting concentration, do you change the volume?
No.
Okay, now if you are putting wait, I need to have another answer. Faith, can you give me your answer? Faith,
I don't know, teacher.
sorry?
I don't know.
You don't know? Okay. Who is
Yeah.
having problem to get this answer for K? Show your, if you are having problem, you show a light to show me. Having problem to get answer, the factor for the K? Okay, no problem. Then we should hear from Trishan. What's the factor?
So I put the concentration of hydrochloric acid. Sir.
Okay, you put concentration as well. Okay, now we continue. Yes, Chasnavi, you have problem as well. Chasnavi, is it you are having problem? Okay, now I'm going to explain to you. Okay, now, when you want it to be having higher rate of reaction, now we are going to look at the factor. Now, what are the factors that affect the rate of reaction? Number one will be the size. Okay, now number two will be the temperature. Number three will be the concentration. And number four will be the catalyst, the presence of catalyst. In this case, we are not talking about the pressure because of what? Because we are not using a gas. Okay, now we are having initially the 50 centimeter cube, 1 mole per decimeter cube of hydrochloric acid using the magnesium powder. Now, when we are already using the magnesium powder and we want it to be having higher rate, meaning we are going to cross out the size. We are not going to talk about it unless initially we are using the magnesium strip. Okay, next part. We can use actually the temperature. Okay, oh, I spelled the concentration. I spelled the concentration wrongly, I'm sorry. Now here, we are actually can talk about the temperature, where when we increase the temperature, of course, the rate of reaction will be higher. I hope you agree with me. But if we are increasing the temperature, we have to consider another one problem. Will we have the same volume of gas being released? Now, the answer should be yes. Why? Because the volume of gas from here is determined by the number of mole of the reactant used. Okay, so now if we are using the temperature, it will not affect the rate of, it will not affect the maximum volume of gas produced. Of course, when our friend said using concentration, which is higher, yes, it will increase the rate of reaction, but at the same time, it will also change the volume of the gas which is produced. Why do I say so? Okay, I am going to show you the calculation. Okay, now what are we going to have now will be the magnesium that reacts with the hydrochloric acid, HCl, giving you the magnesium chloride and the hydrogen gas. Okay, now from the question that we have here, we know that we are having the magnesium powder in excess, and we are having this the hydrochloric acid, which is 50 centimeter cube, 1.0 mole per decimeter cube. Everybody count for me, calculate please. The number of mole of HCl. Okay, can I have answer from you? Monisha, what's the number of mole of the HCl? Monisha, what's the number of mole of the HCl? Lishina, what's the number of mole of the HCl? What formula are you going to use?
MV over 1000.
Yes, it's MV over 1000. So now, Monisha, what's the number that you are getting for the number of mole of HCl?
0.05.
Okay, it's 0.05 mole. 0.05 mole. If she's correct, if she's wrong, please correct me. Okay, now from here, we will know that when we want to know the volume of gas released, we are going to put the ratio, the HCl ratio to the hydrogen gas. Okay, and we will find that the ratio is 2:1. When we are having ratio 2:1, meaning 0.05 mole is to 0.0125 mole. Okay, can follow? Meaning, if you want the volume of the gas which is released, which is the same, later for the next set, let's say you are repeating. Any question?
Teacher, the mole should be 0.025.
Yeah.
The hydrogen. Yeah.
Oh, sorry. Thank you very much. Okay, so what's the mole just now? You say 0.025, Okay. Oh, thank you very much. This is the number of mole of the hydrogen gas. This one, for the hydrogen gas. Now, meaning to say, when you want to get the graph which is shown in the question just now, the number of mole that you get later should be 0.025 as well. Now, let's say I repeat my experiment. Just now you said you are going to change the concentration. If I am changing from 1.0 to 2.0, and for sure the rate of reaction will become higher. But when I change it to 2.0, do you notice that the volume of the hydrogen gas release will also be higher? Therefore, when you are talking about you increase the concentration, you have to talk also about the volume of the acid. so that you can do a calculation to get back the same number of mole. Can understand what I mean? I hope you are okay. If you are okay, you show me a like. Are you? Okay, Shasnavi, are you okay? Devnas? Okay. So now I'm going to move on to the next part of our question. We are now going to look at this. So our question here, asking you to suggest a fact, something that you can do to get curve K. The best answer will be increase the temperature. Okay. Now, the rate of reaction of curve K is higher than L. You are going to explain based on collision theory. Now, if our factor is temperature, so what is the next sentence? What is the sentence next to explain based on the collision theory? Okay, can we hear from our friend Jasnik?
Rate of reaction K is higher than L.
Rate of reaction of K is higher than L. Did you see the question is already shown to you? The question is already written this. So if you write this sentence again, you will get no marks. We are now talking about the explanation based on collision theory. Okay. Now, when we are talking about this collision theory, did you notice that in part 1, we have already mentioned about the factor, which is the temperature. So in part 2, we are not going to mention about the temperature anymore. So what will be the next sentence that you are talking about? Vernon, can I get your answer? If we are talking about the temperature, what will be the keywords?
Kinetic energy
Yes, kinetic energy of who?
of particles.
Yes, so for curve K, the kinetic energy particles is higher. Or you can say the kinetic energy of particles in reaction K is higher than L. Follow? Okay, now next part. When we are talking about the kinetic energy, what will be the next? Remember that, look at the marks given here, you are getting only 2 marks. If you have only 2 marks, then straight away, you are going to talk about the frequency of effective collision. We are now going to straight away talk about the frequency of effective collision. Now, what are the particles which collide with each other? Anyone? Anyone? What's your answer?
Magnesium and hydrogen.
Yes, Faith. Magnesium and hydrogen. Magnesium, what? We are talking about the particles. We are talking about the particles. So magnesium?
Magnesium atom and hydrogen ion.
Good. Okay. Therefore, the next sentence we are talking about the frequency of collision, the frequency of effective collision between magnesium atom and hydrogen ion is higher in K compared to L. Okay. Now, if you are still confused with this atom and ion, you please refer back to the video yesterday. Okay, next part. Now, the final volume of gas obtained in curve M is half of the final volume of gas obtained in L. Give a reason for this occurrence. What is the reason? Why is this M having only half the volume of the L? Do you have any idea on this? Anyone wants to suggest your answer? No one. No one? Okay. Now, actually, the answer should be, what's the answer? Just now from our calculation, why is it half? Why is it half? We can actually explain based on the calculation. If we want it to be the same as this one, we are going to use the same number of mole of hydrochloric acid and it will produce the same number of mole of hydrogen gas. So now, when you want it to be half, meaning your answer, you should say that the number of mole of hydrochloric acid is half compared to the one in M is half compared to the one in L. I repeat, the number of mole of hydrochloric acid in M is half compared to the one compared to the number of mole of hydrochloric acid in L. Okay, any problem? Yes.
Can it be half of the volume used?
No, cannot. Why? Because half of the volume is already mentioned in the diagram here. Now the question is asking you why the volume is half. Okay. The volume is half. It is due to the number of mole of the hydrochloric acid used, which is half. Okay, any more problem? Any more? No more? Okay, if no more, then I think this is about our question 1. Okay, this is our question 1. And we are going to continue with our this second session on the question 7C that we have not discussed about the answer yesterday.